Hello world, this is Craig. I love panel meters. I'll admit it. When my brother and I were little, we grew up right next to a engine room. My dad was the chief engineer, and so we basically grew up around this engine room, and that thing was full of panel meters. A lot of electrical meters, a lot of pressure gauges, temperature recording charts, things that you could just sit there and watch for hours. Panel meters basically do nothing. But I've always had a liking for panel meters, and so it's high time to make a panel meter clock. Now, the first thing that comes to mind is, does the world need another panel meter clock? If you look, this is not a new idea at all. I'll tell you that right up front. If you do a Google search on say, panel meter clocks or voltmeter clocks or something like that, there will be dozens, if not hundreds, of results that come up for people that have made these before on, Hackaday. There's some available on Etsy. There's just panel meter clocks are not a new concept. But what I want to do is a little bit different. This isn't about telling time. If I want to tell time, I'll look at my watch or I'll look at a clock on the wall. This is about the panel meters. I like the panel meters. The clock is just there to have them move. So what I want to do with my clock is to have the electronics handle any kind of a panel meter that I happen to find that I really like the display. I want to pick a panel meter that has a display that I like and use that to display part of the clock. So that means that, my meter scale may not exactly line up. I'm not going to find something that's 0 to 12, and that's fine. That's one of the things, if I looked at all of these that showed up on the Google search, the things that they all seem to have in common is, people print out a new display and completely get rid of the original display. They, have 0 to 12 and it says hours across it, or 0 to 6 and it says minutes across it, and so I want to leave the display exactly as they are. So for example, this is a panel meter I have, and I don't know when this was made. This is a millivolt meter. It's full scale. It's 100 millivolts, and that's inconvenient for a clock, but I've seen these that are, or I've seen them in kilovolts that go from 0 to 12. And a 0 to 12 or 0 to 15, kilovolt panel meter would be really a nice use for the hours. I don't know how old this thing is, but the last time it was calibrated was 1913, if we look at the little calibration chart inside the cover. So I have no intention of modifying, this meter. I'm just going to make my electronics so it can run that. So what I'm currently thinking of is having a meter that is 0 to 12 or 0 to 15 to show the hours, and then I can get one that is 0 to 50 maybe to show the week. I like knowing what week it is of the year, and 0 to 50 is just fine because really nothing happens after Christmas anyway. So 0 to 50 to show me the week, this guy to show me the hour, and then I'm thinking that for minutes I could have somebody that goes from 0 to 60, but that's pretty uncommon. You don't see 0 to 60, you see 0 to 50s, you see a lot of 0 to 120s. But I think to show the minute, what I'm going to do is use something like this galvanometer that goes from plus to minus 30. And so that's going to be in for this particular meter in microamps. And so then I will have this display, 30 minutes before the hour, and then up to the hour, and then 30 minutes after the hour. And then at 30 minutes after the hour, it'll flip back over to before the hour. So, you would look at it and say, okay, well, it's 10 after, 20 after, or it's 20 till or 10 till. So I think that would be, a little slick to have this a bipolar one rather than just, 0 to 60. So that's my goal for this project. And the first thing that I have to decide is what kind of meters am I going to be able to use? So when I'm searching eBay or wherever I come across meters, I need to know whether or not I can use those meters. So I have to make some decisions in terms of my electronics as to what kind of a signal do I want to generate for the various kinds of meters. Okay, so let's look at the overall goal. What I want to have is a meter that displays the week, and then standard hour, minute, and second. Okay, this is going to come, I'm going to have a microprocessor. That's going to probably have like a real-time clock up here, so I can get an accurate clock. Probably going to put some kind of an interface on this, say RS-232. just because I like RS-232. I'll have a manual interface, which is going to be, switches and so forth for setting. And then each of these guys is going to have some kind of a driver down here to drive these displays. And that's what I've got to decide is, is it going to be current driver, or is it going to be voltage driver? Is it going to be unipolar, or is it going to be bipolar? And I mentioned earlier I wanted this guy to go from plus 30 to minus 30, so that tells me if I want to do that, I need to be bipolar already. And it's what's going to be the compliance on these? Am I going to just stick with the microamp? Am I going to go to the milliamp? I'm going to go to millivolt, volt. What's going to be my compliance on any of these? And of course, all of these drivers are then going to be controlled by the microprocessor. So my intent is be able to just have my meter sitting there with a couple of wires going off to the back to this little control board, and the control board is taking care of all of that. As I get a meter that I like and I put in here, I can then change that, physically, maybe add a little driver or do something to this, or just pick on a different part of the circuit where that circuit can drive that particular meter. So what am I going to do for these drivers? Well, let's first look at the different kinds of meters. Okay, I would say there are 3 different kinds of meters. First kind of panel meters we have are direct ones. And these are both direct ones. This guy directly measures whatever it's displaying. And so this one is measuring millivolts and it's displaying millivolts. There's some other direct ones I've got sitting here. That is a current. This one is DC amperes and goes up to 20, and by the looks of this meter, I would not be surprised if this is a direct panel meter. So in other words, the 20 amps that this thing can measure are going directly through that meter. So we're putting current in and current's coming back out, and so it's directly measuring that current. So we can have a direct meter, it's a voltmeter, come out here, and it's just directly measuring that that voltage. We can also have a direct current meter that's coming in, and somewhere we have our load, comes through here, it goes through an amp meter and then back out, and then this is direct measuring the current. And I would say for the most part, a direct meter is actually going to measure what it displays. So if you have a meter that says current on it and it's a direct meter, it's actually measuring the current. If it says voltage, it's probably actually measuring the voltage. And of course, those are simple. And for my system, I have to decide if I want to do direct, what's the maximum voltage, the maximum compliance voltage that I want to have my system be able to put out. Is it going to be 1 volt? Is it going to be 10 volts, 15 volts? I have to decide what my maximum compliance is. Same with the current. I have to decide what's the maximum current if I want to use a direct meter that my system's going to be able to put out. Now the next category of meter are, an indirect meter that are probably measuring something different than what they're actually displaying. And they do that by either using a shunt or a multiplier. So you may want to say that this is a multiplier and that's a divider. In that case, let's look at the shunt one. We've got a system that has driving a current. It's got a motor or whatever, and it's going to go through a very low resistance shunt. And this may be a shunt that say, at 1,000 amps, the voltage drop across that shunt may be 100 millivolts. Okay, we're just using Ohm's law here. V equals IR, and it's going to generate some kind of a voltage drop across that shunt. And then you just buy these panel, they're called a panel shunt. You just buy these panel shunt, get a 1,000 amp, 100 millivolt shunt, or you can get down to like a 1 amp, 50 millivolt. And so those are pretty typical. It's going to be either 50 millivolt or 100 millivolt shunt, and then whatever current you need for your full scale. Of course, once you have this kind of a system, now you've got that shunt that's going to generate the voltage, and so now you're just using a standard voltmeter to measure the voltage drop across that shunt. But in this case, we're measuring a voltage, but we're displaying a current. Okay, so you'll see meters that may go, from, say, if it says 0 to 1,000 amps. Well, we're probably not running 1,000 amps directly through that meter. We're probably using a panel shunt, and that's a 100 millivolt or a 50 millivolt panel meter that just has a display that goes from 0 to 1,000 amps. And you can look at some of these old meters, if you're picking a meter out to buy, you can look at it and it will probably say on it somewhere. In this case, for example, this may say FS equals 100 millivolts. So even though the display may go from a 0 to 1,000 amps, down here at the bottom somewhere, there's our needle. Somewhere at the bottom, it may say FS equals, 10 millivolts. And that's what they're telling us. They're telling us that the full scale of that meter is 10 millivolts. So even though the display says 1,000 amps, its full scale is only 10 millivolts. Full scale might be 100 millivolts, 50 millivolts. It depends on what kind of a shunt that was intended to be used for. Okay, so this is a shunt or a dividing one where you're dividing the signal down and measuring something that is much smaller than the actual current. Now, instead of measuring high currents with a shunt and a voltmeter, the complement to that is to measure high voltages with a multiplier. So in that case, let's say we've got a transmission line that's coming in here. And so this transmission line, let's say this has, 15 kilovolts on it. Well, one way to measure that 15 kilovolts is to take that through a multiplier, which is nothing but a very, very high resistance, giga-ohm, mega-ohm kind of resistance. And then that will come through a meter that's an amp meter. And again, because this is, let's say this is 15 kilovolts. Let's say we have a 15 mega-ohm resistor in here. So that means that in reality, this is going to be passing 1 milliamp. Okay, so at full scale. So again, our display on our meter, we got this, it may go from 0 to 15, and this may down here, it may say kilovolts, proudly display this as kilovolts, but actually down here, this may say full scale equals 1 milliamp. And so this is a multiplier because it multiplies the reading of the meter. So not only is it multiplying the reading, but it's changing it. Here we are measuring current, but we're displaying voltage. Okay, so that's freaking in the second category where we're dividing and multiplying. Frequently we will have the meter displaying units that are opposite to whatever that meter actually has. So when you're going out and you're picking a meter, now you've got to guess, unless, this comes with, sometimes they'll have instructions on the back, or they will say, use external shunt, or you'll see the box and you can find the manual for it. But this one, for example, it's possible this is actually carrying that, which I think in this case is likely, or maybe this was just meant to go on a 20 milliamp shunt, and this is actually just a 25 millivolt meter. One way to tell is I can start, I can put 25 millivolts on this and see if I move the meter, and if it doesn't, I can go up and up and up. And eventually, if none of that works, I start running some, current through this and see if at 5 amps it actually displays, anywhere close to 5 amps. So once you have the meter, it's easy to tell. You can ohm it out. Just put a voltmeter on this, and that'll give you a great indication. On some things, you want to be very careful. Obviously, putting a voltmeter, you put a voltmeter on this galvanometer, and you could easily damage that. The voltmeter itself could push more current through this than that can handle. So you don't want to just jump right to the voltmeter. I'm sorry, I said voltmeter, I meant ohm meter. You put the ohm meter on this galvanometer, and just the few volts that it puts across it could seriously damage that galvanometer. Okay, so the direct reading, the multiply, divide reading. The next kind of meters are ones that I would say use transformers. And of those, first one we're going to talk about is the current transformer. Current transformer, let's say that we have a line and this is passing current. And so we will then take that wire and we will put around that a little pickup transformer, a current transformer. They call them donuts in the industry. We'll put that around that, and that'll be just a transformer that is wrapped around this wire. That transformer will generate a voltage, and so we will measure that voltage with a voltmeter. So now we've got a current. That current is going to generate in this current transformer, this donut, a little voltage, and that voltage is what's going to be displayed. So this is the same kind of thing where we've got a meter that will say amps, and this goes from 0 to 100 or whatever it happens to be, but down here at the bottom it may say full scale equals 10 millivolts, because this current transformer is designed such that you would buy the current transformer that would tell you that at 100 amps this will put out 10 millivolts, or it'll put out 100 millivolts, exactly the same as the shunt did earlier. Where was that shunt one? Exactly the same that the shunt did earlier, but rather than actually have a shunt in the circuit to generate a voltage, we have a non-contact transformer that's just the wire goes through to generate the voltage. So again, just like we did before, this one is measuring current, but then generating a voltage and displaying voltage, but when it displays it, the engineering units are actually in amps. Okay, so that's the current transformer. The other one is a potential transformer. In that one, let's say we have a high tension line, or we've got something that's higher voltage, like so we've got 15 kilovolt line that's coming in here, and what we will connect to that is a transformer, and that transformer will have a secondary that is just a fraction of the initial windings. So we put a voltage on this guy, it's going to pass a certain current, but this is going to pick up a very, very small amount of that, and it's going to generate a voltage that it's going to display. Now some line voltage or big transformers will actually have this transformer built in, so they've got a tap for just a little voltage pickup. But with these potential transformers, again, we will have something here that will say volts or maybe kilovolts, 0 to 100, but in this case it's actually measuring volts, and it may say down here full scale is equal to 100 millivolts. Or some of these would be a larger voltage, full scale equals 120 volts, maybe AC or DC. So these are current transformer pickups and potential transformer pickups. So indirect, non-contact kind of things versus the old school direct with the multiplying resistor or with a panel shunt, versus just a straight direct where the actual voltage is being measured by the meter or the full current is going through the meter. So these are like the different categories of meters, and now it comes down to, when you're buying the meter, is to guessing, if there's no documentation for it, which type of meter this is. And as I said earlier, the hints can be the weight of the meter, the size of the lugs on the back, whether it's passing the full current, whether it says something down here at the bottom about Fs equals a certain value, or just guessing as to whether it's going to be one of these meters, what the engineering units are compared to what the meter is actually measuring. So I've done a little bit of browsing on the internet for meters that are available at a reasonable cost. And I think this is where I'm going to be. I'm going to want to have a system that can output on any of the outputs a current, say in the microamp or milliamp range. I'm just not going to make a system that goes up into the amp range. I don't want to have a giant power supply running this thing. I just want a little wall wart or a battery. So I'm going to have current that's in the microamp or the milliamp range, and then the next question is, for that current, if I want to have milliamp, how much compliance do I have to have? In other words, what kind of a voltage do I have to have available to drive that current? And that depends on the internal impedance of some of these devices. How much, if I want this to display 100 millivolts, how much current do I have to be able to drive in order to get that to display? Or if this is a microamp meter, what kind of voltage do I have to have on that to get it to display? So in terms of current, I'm going to be able to handle meters that are in the microamp or the milliamp, but I have to decide what my compliance voltage is going to be on that. And then the complement of that is that for my voltage, I think I'm going to want to have, the most common are going to be millivolt, volt, and I think I'm going to want to be able to go up to, say, 15 volts on this. Anything above that gets a little bit dicey and a little bit harder to handle. Electronics get more complicated. So I think I'll want to be able to go anywhere from, the fraction of a millivolt to 15 volts on the voltage output. And then also the question is, what is my compliance current have to be? So if I want to output 15 volts, depending on the impedance of that meter, what kind of a demand that meter has is going to tell me how much current I have to be able to output. So for example, can I just do this with an op amp? If I have an op amp that can put out 20 milliamps, is that going to be able to swing most any meter I want to measure with that 20 milliamp? And that's what I've got to start looking at meters that I've got and measuring some of my meters, and I'll do that next time, and we'll see if I can come up with a compliance voltage that I'm happy with. But I'm pretty sure that this is where I want to be. I want to be able to go from a microamp, and the other thing is this is going to have to be bipolar. I want to be able to go plus and minus probably on both of these. Because if I want to display this, where'd that one go? This was the one I wanted to use for the minutes. From minus 30 to plus 30, this is a galvanometer, so it's going to be in microamps. I need to be able to go from minus 30 microamps to plus 30 microamps to display my minutes. I saw a meter just like this that it's displayed as kilovolts. It goes up to 15, but it's certainly, from the date of that, it's not one that was meant to be used with a potential transformer. It was one that was meant to be used with a multiplier. So I'm guessing that it is probably a full scale in microamps. The things that were meant to measure kilovolts will have very small full scales because if we go back to that this multiplier, they want this to be very, very big. So in case you happen to put your finger over this and touch this, the current is going to be so small it's not going to hurt you. Because keep in mind the danger of this. If you break this circuit right there, this guy right here immediately goes up to whatever this voltage is right here. So if this is on a 15 kilovolt line, you break the circuit right here, so this is no longer drawing current. This right here is going to go up to 15 kilovolts. And of course 15 kilovolts can do some damage to your heart. So these resistors are usually very, very big in order to get this very, very small. Instead of 15 mega ohm, for example, this could be 15 giga ohm to get this, instead of the milliamp of current, getting this down to a microamp of current. So that might be a 15 giga ohm multiplier, although that's pretty high. I don't think I've seen multipliers that were in that giga ohm range, but that would get it down to the microamp. So that would protect you from instant death at least. So that's yet to be determined. If I might have to buy that 15 kilovolt meter and connect it up and actually see what kind of current it takes to drive it. So that's where I am now. I think I'm going to go ahead and start thinking about this clock, looking at some of the meters I have, and just browsing and seeing if I can find meters on eBay that I like, that are reasonably priced, and go from there. Once I've got the compliance and things set up, then I have to do things like decide how many outputs I want to have. If I just have weeks, hours, minutes, and seconds, that's only 4 outputs. I might want to throw in a couple of extra outputs if I want to display something else, barometric pressure, who knows what. I'm going to have a manual interface on this, as I mentioned, for maybe setting the time, maybe some old industrial indicator lights to show something. I'm not sure. I got to pick a microprocessor, real-time clock, and then, but the big question is all of these drivers down here, these control drivers, are they going to be voltage or current, or what's going to be their compliance voltage? And then we'll do the schematic, we'll lay out the PC board and send these things off and get them back. Okay, so that's going to be this project, and I was going to go ahead and document it as we go along. You see all of these clocks, and sure, it's a fun project and it's a good idea. I like a lot of these clocks, but I just want something that highlights the meters themselves, and showing the time of day is not the main purpose. The main purpose is just to show off some of these meters that I have, either just sitting around or that are readily available at a reasonable price. Okay, so that's it for this video. The next video that will be in this series will measure some of these and get an idea as to what we need to have for a compliance voltage, so that we can pick how we're going to drive some of these signals. All right, so that's it for this one. I appreciate you watching. If you think you found something useful, Of course, like and subscribes are encouraging, and otherwise I will talk with you later. Bye-bye.